But these vectors here doesn't belong to T2, so the rank of T2 can increase. Right? And of course, the paper has a lemma which goes into the details of the math, so I'm just trying to give you a graphical picture. Now, all right, so here we have, we found L beta, say we found L beta, right? Now, the space between 1 and 4 is actually C and CA, vectors in C and CA. Now, if, before that, I should show you that. This is what we call phase 1 observer. There are 3 types of observers you can find. If L equal to L beta, now these are L beta, can be found from there and there. If L equal to L beta satisfies condition 1, we know it satisfies condition 1. But if that also satisfies condition 2, then we found the lowest possible observer. That is phase 1 observer. If these vectors satisfy condition 2 also, well, that is one type of observer we can have. But what happens if it's not satisfied? Well, then comes the other type of observers. Now, if it cannot be satisfied, if condition 2 cannot be satisfied for L equal to L beta, right? Now, consider there are some more vectors in this space, right? We can find vectors in this space where still it is possible for you to satisfy condition 1, right? And the rank on both sides is going to increase now, because if you pick vectors from here, T3 is also going to increase, the rank of T3 is going to increase, rank of T2 is going to increase, right? So we can satisfy condition 1, but if condition 2 cannot be satisfied as it is, and I pick vectors from here to satisfy condition 1, that rank deficiency in condition 2 is going to be carried forward. So by just choosing vectors in this space and adding it to L will not satisfy condition 2. It cannot be done because that rank deficiency is going to be carried forward. So what we have to do in this case, if this condition 2 is not satisfied, try to pick vectors in here in order to satisfy condition 2, right? But in trying to pick vectors here in this space, we also have to ensure that we don't violate condition 1. We can't violate condition 1. Yeah. So this is the space CAC. So imagine the rows of CAC. This is that space spanned by those 4 vectors. So in here, there could be some vectors which will not violate condition 1. And those vectors that will not violate condition 1 is inside circle 3, between 3 and 1. Not everything in that space will not violate. Some will violate, some won't. And these are the vectors that will not violate condition 1 if I append more vectors. But if I append vectors from here, notice that condition 1, the rank on the right-hand side and left-hand side will not increase. It's not violated, but it doesn't increase either, because they already belong to T2 and T3, because this is the T3 and T2, the biggest cycle, right? So these are the conditions. Now, okay, now we are up to phase 2 observer, second type of observer. So if this is L beta, there and there, to that L beta, if you can append some vectors from here and satisfy condition 2, then we found a phase 2 observer. We found a phase 2 observer. Suppose we can't do that. Of course, all these searches, I mean, we can guarantee, because we know exactly the vectors here are finite, because we are looking at only the basis vectors. We can guarantee. And if we satisfy it, again, that is going to be the minimum. Yeah, that's going to be the minimum. Now, suppose we can't do that. So all the vectors that you find here, you append that, and you can't satisfy condition 2. You can satisfy condition 1, but can't satisfy condition 2. All right, so what do we do then? We only have these vectors to play around with now on the outer ring. Now, in this, we can find a finite number of vectors. Let's say the dimension of that subspace is Q, right? So we can find Q vectors in here that we are able to append to L, right? That will satisfy condition 1. Right? But of course, the rank on both sides on condition 1 is going to increase when we do that. Right? So let's say this is one of the vectors that we can add to L beta. This is one vector. Of course, if you add that to L beta, we know we can't satisfy condition 2. We need to still add vectors from this space here. We need to do that because that rank deficiency is going to be carried forward. We have to add stuff from here. Now notice that the number of vectors that we can choose from this space here now, which will not violate condition 1,